let's determine the area bounded between those two curves exclusively in quadrants 2 and 3. So nothing down here, just up here, and we're going to find the area bound between them, which is going to be all this stuff right here. Okay, so this is a situation where we do outer minus inner, and we've done this before in a rectangular sense, like if we had a graph that was find this area right here, we would do f minus g, right? Well, now we're going to do the same thing, only we have to do our little thing where we have the 1/2 in the front and we square it. So first of all, let's decide which equation is which. And whenever you see a sign, just a sign, you're going to have a circle. Same with cosine. So the circular graph, just circular, is sine. It's just good to know. If you don't know that, it's okay. We'll grab a calculator in a second. So this is 3 sine theta. By the way, notice that the radius of this is, well, the diameter of this is 3. The radius is 1.5. So, and that 3 is the diameter in this case. And this little graph right here, that is the inner function, is going to be 1 plus sine theta. And what I want to do is find, again, the area in between these two. Well, in order to do that, I'm going to have to set up some stuff. So let's start setting up stuff. 1/2 for sure, from somewhere to somewhere. And my somewheres are angle measurements. And it's from this angle to this angle, with bad handwriting, from here to here. And I don't know what that angle is. This is going to be theta equals something, and this is also theta equals something, but I don't know what those somethings are yet. We'll cross that bridge in a minute. And we're going to do outer minus inner, and the outer one is 3 sine theta, so 3 sine theta minus the inner one, which is 1 plus sine theta, and then d theta, and I'm going to need to parenthesize that. Now, here's what I've left off. First of all, the obvious, but also, because we're finding area in polar form, we need to square it. And we square them individually. It's like I'm finding all this area, including what's not shaded, and then I'm subtracting, that's this part, and then I'm subtracting the part that's not shaded, that's that part. Okay, so now the task is to find what goes here and what goes here, and we'll switch to red just to make it look super important. And how do I find it? Well, without a calculator, I would find it this way. I would set 3 sine theta equal to 1 plus sine theta, and I'd solve for theta, because that's where the two graphs intersect, right? So subtract sine theta, you get 2 sine theta equals 1 divided by 2. So I need everywhere that sine is equal to 1/2. We've actually seen this similar idea here, and it is going to be pi over 6 and 5 pi over 6. And we could do this on a calculator, but we would have decimals that just get a little out of hand. So pi over 6 and 5 pi over 6. So very quickly, let's switch to calculator, to the calculator. 1 plus sine theta, and then 3 sine theta. I'm going to go to a standard window. You're going to see everything that you just saw. There it is. Zoom in a little bit. There it is, okay? And if you wanted to find this point of intersection, you press second and calc, and oh man, you can't find it, right? You can't. So those tools aren't always available. And so what I'm going to do, we do have some derivative tools. It's lovely. What I'm going to do actually, just in case I don't know that, I'm going to go to the table, and I'm going to guess some things. For example, perhaps I thought that this was at pi over 4. They should have the same value, and they don't. Okay, well, maybe it was at pi over 3. Oh, they don't have the same value. You know what? Maybe it was pi over 6. Oh, there they are. Okay? Another way to find it, if you don't want to go through this, or the decimals are so crazy and ridiculous, press mode, go to function, and then type them in like functions. So I'd have 1 plus sine x and 3 sine x, and I'm just going to graph them. And now I do have the tools at my availability to find the point of intersection, and that point of intersection will truly be the angle measurement. And there's infinite number of them, but we're looking for this one and this one. So intersect, first curve inner, second curve inner. We have a cursor close to the point I want. There it is, 0.053. That's it, which is pi over 6, just saying. Just good to know. Now you know. All right, let's move on. And the calculator comes back out. 1/2 math 9 from pi over 6 to 5 pi over 6 of, whoa now. You know what? We'll go with it. I'm in function mode, not polar mode, but that's okay. We're going to use x's, not thetas. And these functions are typed in there. Now, let's be careful. Let's be very careful because this one is my second r, and this one is my first r, but they're in reverse order, and I put these in as x's and y's instead, so we'll do that. Squared minus. You can do this in function mode. It's totally okay, and you should get the right answer, which should be, wait for it, surprise, huh? Exactly. Exactly. Amazing, isn't it? Pi shows up everywhere. Thanksgiving dinner and all kinds of other places. Isn't that delicious?